Consider for a moment the speed of light. We say nothing can go faster than it. We treat this as a cosmic speed limit, as if the universe had posted a sign somewhere declaring maximum velocity. But here's something remarkable that almost no one tells you. The question itself, the very idea of asking why nothing can go faster than light. This question is backwards. It's like asking why water can't be wetter. The universe doesn't work that way. And once you see what's really happening, once you glimpse the actual architecture of reality, everything you thought you understood about motion, about time, about the fabric of existence itself, it all dissolves into something far stranger and more beautiful than you ever imagined. Let's begin with what we think we know. You're sitting there right now, reading these words, and you believe you're stationary. Perhaps you're in a chair, perhaps standing. You feel solid, unmoving, planted on the ground. But this is a profound illusion. You are hurtling through space at extraordinary speeds right now. The Earth spins on its axis at roughly 1,000 miles per hour at the equator. We orbit the Sun at 67,000 miles per hour. The Sun itself tears through the galaxy at 500,000 miles per hour. The galaxy rushes toward Andromeda at 250,000 miles per hour. And the whole local group of galaxies participates in even larger motions. Add it all up, and you're moving at incredible velocity through space right now as you read this. But you feel nothing. No wind in your face. No sense of motion whatsoever. Why? The answer that Galileo gave us 400 years ago was this: there is no such thing as absolute rest. There is no privileged position in the universe from which to measure all motion. You are stationary relative to your chair. Your chair is stationary relative to the room. But the room is moving relative to the Earth's surface. The Earth is moving relative to the Sunday, the Sun relative to the galactic center. Motion, we discovered, is always relative. It only has meaning when measured against something else. This was a profound insight, one of the great demotions in human understanding. There is no center. There is no absolute frame of reference. There is only motion measured against other motion. Now here's where it gets strange. If all motion is relative, if there's no absolute rest, then shouldn't all velocities add up in simple, predictable ways? If you're on a train moving at 50 miles per hour and you throw a ball forward at 20 miles per hour, someone standing by the tracks sees the ball moving at 70 miles per hour. Simple addition. This is how we experience the world. This is what Newton told us to expect. Velocities add. Speeds compound. If you're moving and you shine a light forward, shouldn't that light be moving faster than if you were standing still? This seems obvious, inescapable. The light should inherit your motion and go even faster, but it doesn't. It never does. And this fact, this stubborn refusal of light to behave the way our intuition demands, this is the crack in reality through which we glimpse something extraordinary. In the late 1800s, physicists were deeply puzzled. They measured the speed of light coming from stars as Earth moved toward them in its orbit. 6 months later, they measured light from the same stars as Earth moved away. The speed should have been different, should have varied by at least the velocity of Earth's orbital motion, but it didn't. The speed of light was the same, always the same, exactly the same. No matter how you moved, no matter how you measured it, light traveled at precisely 186,000 miles per second. Not approximately. Not on average. Exactly. Every single time. This was deeply disturbing. It violated everything physicists thought they understood about motion and velocity. Then came Einstein. Picture him in 1905, working in a patent office in Switzerland, thinking about what it would be like to ride alongside a beam of light. If you could catch up to light, what would you see? Would you see the light wave frozen, stationary beside you? But that's impossible. Maxwell's equations, the fundamental laws of electromagnetism, don't allow for stationary light waves. Light has to move at light speed. Always. There's no such thing as light standing still. This led Einstein to a radical thought. Perhaps the problem isn't with light. Perhaps the problem is with our concepts of space and time themselves. Perhaps they're not what we think they are. Perhaps they're not separate, absolute, universal. Perhaps they can bend, stretch, compress. Perhaps time itself can slow down. Here's the revolutionary insight. We think of space and time as the stage on which events play out, as the backdrop against which the universe performs. But what Einstein realized was that space and time are not the stage. They are part of the performance. They participate in the action. They flex and warp and change depending on how you move through them. And here's the key. Here's the thing that changes everything. You are always moving through space-time at exactly the same total speed. Always. Right now. Every moment of your existence. You move through the combined dimensions of space and time at exactly the speed of light. Not approximately. Exactly. This is not a speed limit imposed from outside. This is the speed at which reality itself operates. This is the tick rate of existence. Let me make this clearer. Imagine space-time not as separate things, space over here and time over there, but as a unified fabric with 4 dimensions. 3 of space, 1 of time. You are always moving through this 4-dimensional space-time at light speed, always. But here's the crucial part. You can divide your motion between space and time in different ways. If you're sitting still in space, not moving spatially at all, then all of your motion goes into the time dimension. You are moving through time at maximum speed, aging as fast as physics allows. But if you start moving through space, if you get up and walk, or drive, or fly in a rocket, then some of your motion through space-time gets redirected into spatial dimensions. And here's the consequence. You have less motion left for time. Time slows down for you, not subjectively. Actually, measurably. Your clocks run slower. Your atoms vibrate slower. You age slower. This isn't theory. This is measured fact. Atomic clocks flown on airplanes run slower than identical clocks left on the ground. GPS satellites have to correct for time dilation, or they'd be off by miles within hours. Now push this to the extreme. Imagine you could somehow accelerate to the speed of light. Imagine all your motion through space-time got redirected entirely into spatial dimensions. Then you'd have 0 motion left for the time dimension. For you, time would stop. Not slow down. Stop. Completely. This is what happens to a photon of light. It moves through space at maximum speed, which means it has 0 motion through time. From the photon's perspective, if we can speak of such a thing, it is created and absorbed in the same instant. The entire journey, whether across a room or across the universe, takes 0 time. The universe is frozen from the photon's point of view. Light does not experience duration. It does not age. It does not wait. It simply is instantaneously connecting emission and absorption across arbitrary distances of space. And here's why nothing can go faster than light. It's not because light is special in some magical way. It's because light happens to move in such a manner that all its motion is through space and none through time. That's the maximum. That's all the motion there is to have in the spatial dimensions. You've used up your entire allowance of motion through space-time. There's nothing left. There's no more speed to access. Going faster than light wouldn't mean going really, really fast. It would mean having more than 100% of your total motion pointed in spatial directions. It would mean moving through time backwards. It would mean effects preceding causes. It would mean the collapse of causality itself. The universe doesn't forbid faster than light travel because of some arbitrary rule. It forbids it because faster than light is a meaningless concept, like asking what's north of the North Pole. There is no north of the North Pole. The question dissolves. But wait, there's more. And this is where it gets even stranger. We've been talking as if space and time were just coordinates, just measurements. But Einstein showed us something deeper. Space and time are not passive containers. They are dynamic, flexible, responsive to the presence of matter and energy. Massive objects bend space-time around themselves. They curve it, warp it. create what we experience as gravity. You are not being pulled toward the Earth by some mysterious force, reaching across empty space. You are moving through curved space-time. You are following the straightest possible path through a geometry that has been bent by the Earth's mass. Gravity is geometry, and light, having no choice but to move through space-time at light speed, follows these curves too. Light bends around massive objects not because it's being pulled, but because space-time itself is curved and light follows the curves. This leads to something remarkable. Black holes. Objects so massive, so dense, that they curve space-time infinitely. At the edge of a black hole, at what we call the event horizon, space-time is curved so severely that all paths, every possible future, every trajectory through space-time points inward. There is no direction you can move that leads out, not because you're trapped by a force, but because the geometry of space-time itself has been bent such that outside has ceased to exist from that location. And here's the thing about light speed. At the event horizon, even light, moving at the maximum possible speed through space, cannot escape. Not because it's not fast enough, but because the space-time it's trying to move through is curved back on itself. There is nowhere for the light to go. The speed limit of the universe meets the curvature of space-time, and neither yields. Light falls in, and with it, all information, all causality, all connection to the outside universe. Now consider this. We talk about the speed of light as if it were merely fast, as if it were just a very high velocity. But it's not. The speed of light is the conversion factor between space and time. It's the exchange rate between distance and duration. It tells you how much time you trade for how much space. 1 second equals 186,000 miles. That's not a speed. That's a ratio. That's a statement about the structure of space-time itself. When we measure distances in light years, we're not being poetic, we're being literal. We're measuring space in units of time. 1 light year is the distance light travels in 1 year, which is also the distance space-time extends when you trade 1 year of temporal motion for spatial motion. Space and time are not separate things. They are the same thing measured in different directions. And the speed of light is not a speed at all. It's the slope of that exchange. It's the shape of reality. Here's another way to think about it. Why does anything have mass? Why do particles resist acceleration? We used to think mass was just an inherent property, something objects had for no particular reason, but we now understand that mass arises from interaction with something called the Higgs field, a field that permeates all of space. Particles acquire mass by interacting with this field. The more they interact, the more mass they have. And what does mass do? It resists changes in motion. It makes acceleration difficult. But photons, particles of light, do not interact with the Higgs field at all. They have zero mass. And because they have zero mass, they don't resist motion through space. They move at the maximum speed automatically, without effort, because there's nothing to slow them down, nothing to resist their motion. They move at light speed not because they're going fast, but because they have no reason to go any other speed. Light speed is the default. It's what happens when there's no mass to interfere. Mass is what slows things down. Light is what we get when nothing gets in the way. And this brings us to something profound. We are creatures of mass. We are made of particles that interact with the Higgs field. We have inertia. We resist changes in motion. We experience time passing because we cannot move through space at light speed. Our massive bodies force us to move through time, to experience duration, to age and change and die. But information, pure information, moves as light. Photons carry messages across the universe at the maximum speed, experiencing no duration, connecting distant events instantaneously from their own perspective. When you look at a star, the light that enters your eye left that star years ago. But from the photon's perspective, no time has passed. It is emitted and absorbed in the same moment. The photon connects you to the past not by traveling through time, but by existing outside of time altogether. Every time you see anything, you are being touched by something that does not experience duration, something that lives in the eternal present, something that knows no passage of time. We are the slow ones. We are the creatures who experience time because we have mass. We move through space-time at angles, trading some spatial motion for temporal motion, experiencing the universe as a sequence of moments rather than as an eternal now. And perhaps this is what consciousness requires. Perhaps awareness needs duration. Perhaps thought needs time to unfold. A photon, experiencing no time, cannot change, cannot evolve, cannot think. It is static, eternal, frozen. But we, moving slowly through space-time, we experience change. We experience causality. We see causes leading to effects. We watch the universe unfold. We build memories. We anticipate futures. We exist in time because we have mass, and we have thoughts because we exist in time. The speed of light, the cosmic speed limit, is not a constraint on how fast we can go. It's the boundary that makes thought possible. It's the condition that allows the universe to have a history. And here's the ultimate strangeness. The speed of light is not just a maximum. It's a window into the structure of physical law itself. Why is the speed of light exactly $100,86,000 miles per second and not some other value? Is this arbitrary? Is this an accident? Or is there something deeper? We don't know. But we know this. If the speed of light were significantly different, if the exchange rate between space and time were altered, the universe would be radically different. Stars might not form, atoms might not be stable, chemistry might not work, life certainly would not exist. The speed of light is baked into the fundamental constants of nature, entangled with the strength of forces, the masses of particles, the stability of matter. Change the speed of light and you change everything. The universe is a delicate balance of constants, and light speed is one of the weights on the scale. We exist in a universe where light moves at exactly the right speed to permit our existence. Whether this is coincidence or something else, we cannot say. But we can marvel at it. We can stand in awe of the precision required for complexity to emerge, for stars to burn, for planets to form, for life to think about light and speed and the nature of reality itself. What does all this mean for us? We are creatures trapped below the speed of light, unable to reach it, unable to even approach it without enormous expenditure of energy. As you accelerate toward light speed, your mass increases. Not because you're gaining particles, but because the energy you're putting into acceleration is itself adding mass, according to Einstein's famous equation. Energy equals mass times the speed of light squared. The faster you go, the more energy it takes to go faster still. Approaching light speed requires infinite energy. It cannot be done. Not because we lack the technology, because the universe doesn't work that way. Light speed is not a barrier to be broken. It's the shape of space-time itself. It's the fundamental tick rate of reality. We are locked into a universe where cause precedes effect, where time flows forward, where we experience duration and change in history. This is the consequence of having mass. This is the price of being able to think. But perhaps there's a kind of poetry in this limitation. We cannot touch light speed. We cannot experience the eternal now of the photon. We are bound to time, chained to duration, forced to age and change and eventually cease. But in return, we get to have a history. We get to remember. We get to anticipate. We get to wonder about the nature of light and time and the structure of the cosmos. The photon, frozen in its eternal instant, knows nothing. It is pure motion without thought. But we, slow and massive, we can ask why. We can look up at the night sky and see the light of stars that died before we were born. We can calculate the curvature of space-time. We can deduce the existence of black holes from pure mathematics. We can understand, at least partially, the universe that made us. And perhaps this is the greatest wonder, not that we cannot reach light speed, but that we can understand why we cannot. Not that we are limited, but that we can comprehend our limits. Not that we are small and slow, but that we are aware of how small and slow we are, and we can still marvel at the vast, fast, strange universe that surrounds us. The speed of light is not really about speed at all. It's about the nature of existence, the structure of causality, the relationship between space and time, and matter and thought. It's about how the universe fits together, how the pieces interlock, how the laws conspire to permit complexity and consciousness. We ask why nothing can go faster than light, as if light were somehow special, somehow privileged. But light isn't special. We are. We are the anomaly. We are the strange, slow, massive things that experience time, that build memories, that wonder about our place in the cosmos. Light is just moving through space-time at the only speed there is, the fundamental speed, the speed at which reality itself operates. We are the ones who move slower, who trade spatial motion for temporal motion, who exist in duration rather than in the eternal instant. And in that trade, in that sacrifice of speed for time, we gain something remarkable. We gain the ability to know. We gain the ability to ask. We gain the ability to understand, at least a little, the magnificent, intricate, beautiful structure of the universe that contains us. And once you see that, once you grasp that, the speed limit of the cosmos is not a restriction, but a revelation. You can never see light or time or yourself quite the same way again. You are a thought that got complicated enough to ask about the speed of